Okay, something similar to 19. How about x minus y is less than or equal to 5? And let's, how about 3x plus 4y is greater than 2. I made it real hard, actually. It's actually a lot easier than that. Maybe I should make it 12. Yeah, let's make it 12. So not 2.
Not 2, but 12.
Let's make it 12. Alright. So, not 2, 12. Okay. Not 2, 12. Get it? Little math joke. Okay, so, we've got to do this. How do we do this? Oh my goodness. How about we just find some intersections, or like what the points of intersection, right? So like the x-intercept. This will give me the y-intercept, or no. And then this will give me the x-intercept, so where it crosses the x and y axis. So we'll do it for this one in red, the black one in red. Okay? So, what we're going to do is graph 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Pretty good. I don't know. Always the y on top. Okay. Let's go with oh yeah. If 0 is x, then what's y? Well, negative y equals 5. So what's 5? Or what's y? Negative 5. Okay. You guys always get that weird. You get that weird deer in the headlights look. Like, what are you talking about? So 0 minus y is equal to 5. When you solve these, you just don't worry about greater than or equal to. It doesn't matter. What we're really looking at is what is y? And this, I'm just doing this one. It's all in red. And so I divide by a negative, right? Or I times by a negative, and I get y is equal to negative 5. So I put a 0 in for y, and it goes away because 0 is like nothing. That's why I'm covering it up. So what's x?
Less than 5?
5, yes. 5.
5.
Yeah, 5. 5. It's 5. You guys are getting good. Alright, so, yeah, because what you're doing is you're plugging in a 0. You're saying x minus 0 is less than or equal to 5. We don't care less than or equal to. It's just equal to. It doesn't matter when we're solving. When we're just solving for a number, then we know, okay, then what's x? X is equal to 5. It's just, boom, there it is. It's 5. So we got 5. When y is 0, x is 5. When x is 0, y is negative 5. Oh, we'll graph it. Might as well graph it. So when x is 0, y is negative 5. But when y is 0, x is positive 5. And when I draw my line, now it matters. When I draw my line, this tells me what's going on. And it tells me that it is less than or equal to, well, less than equal to. Remember, we have those little codes. We have less than, equal to, and less than. And then we have greater than, equal to, or greater than, right? And less than, equal to, and greater than, equal to, all tell me that I have a solid line. But less than or greater than tell me dotted line. But when something is less than, I'm going to shade down. And when something is greater than, I'm going to shade up from the line. So that's a really cool diagram to use on your cheat sheet, right? Okay, so right now it tells me it's a solid line. So I might as well just make it solid. Okay. Should I put in the shade now? So here's the thing when I'm shading. This tells me that I'm what? Shading down, right? But if the y is negative, I do the opposite of whatever it tells me. Confusing, huh? Think of it like this. X minus y is less than or equal to 5. I minus x, I get minus y is less than or equal to negative x plus 5, right? But then I have to divide by a negative. We said, or we multiply by a negative. Whichever way, when you do that, you have to flip the sign. So y is greater than or equal to x minus 5. Oh, whoa, look! That's my point of intersection. That's my slope. 1 to 1. And, oh wait, that thing got flipped. Okay. Now, I remember showing you how to flip the signs, and there's one really cool way to do it without doing it. And that's x minus y is this, right? Take your negative y, move it to the other side. Because you want it to be a positive y, right? It's always y equals something. It's y equals mx plus b. So, I'm going to take this and make it green. And I'm going to add y, and I get x is less than or equal to y plus 5. But then, I'm going to subtract 5, and so then I get x minus 5 is less than or equal to y. Right? But wait a minute, isn't that the same thing as y is greater than or equal to x minus 5, and isn't this and this the same? Oops, and this the same? Because remember, the alligator eats the bigger number? The alligator still eats the bigger number. I just put that number on the other side because I wanted to make it look like y equals mx plus b. So that's why we flip the sign. We don't do it just because the book tells us to. We do it because that's really what's going on. But you can make this little thing in your head going, hey, if the y is negative, flip the sign. And that tells me, this tells me that I'm doing the opposite of what's going on. And so it's really greater than, so I'm shading up. Alright, now for the easy part. Green. Oh, just keep it green. Alright, I'm going to plug in a 0. And I'm going to plug in a 0. And I'm going to find these out. So again, if I plug in a 0, what happens? What's y? What's y? What times 4 is 12?
3.
Thank you. That's y. Okay? Alright, let's try this again. I'm going to plug in a 0 for y. What's x?
4.
That wasn't bad. What's x?
4.
More people, maybe. Come on. Okay, so why is it that way? Well, because that's what goes into 12. 3 times 4 is 12, and 4 times 3 is 12. Okay? Alright, so then I can put these in. 0 and 3. So 0 and 3. And then 4 and 0. So 4 and 0. And then all of a sudden, look at that. But wait a minute. I drew a line, and was I supposed to? What's this tell me? They're dotted. Oh, I better erase some. So even when you make a mistake, you can fix it really easy. Okay? So it's a dotted line. Now where do I shade it? Is it a positive or negative y? So I do exactly what it tells me, and it's telling me greater than? What direction's greater than? Up. Greater, up. Okay? That means that all of this area right in here is a solution for both equations. All of this area right down here is a solution for neither equation. The red equation, the green equation. And you can pause that. Hopefully I did it within 11 minutes.